All right, let's go. Hello everyone, welcome back. There was no stream yesterday. I decided that I'm going to take Sundays off. That's gonna be how we do things in the future as well. So it's gonna be 6 days a week. I think that's probably more than enough. I decided that I probably need some time off sometimes. So gonna sit out on Sundays, but every other day of the week we're gonna be here. We're gonna be here live. We're gonna be coding, and today I have actually added a title to the live stream already. This one is going to be the introduction to random terrain generation. Like I said, we're gonna have to do that for phase 1 of the fight, and this is gonna be one of the bigger tasks for us to solve on a technical level. Obviously, this boss is gonna be... Oh, hello Anon, welcome. My most trusty viewer has arrived. Anyway, like I said before, this boss is obviously a collaboration between me and whoever is gonna draw it. And it's gonna, parts of the boss are gonna be carried by my code, and parts of it are gonna be carried by the graphics. And this part, the random terrain generation, is one of the bigger challenges for me. It's gonna be pretty rough, I think, especially since I don't have the framework to work with that I am used to in Extra Mario World. I'm gonna have to do this in a bit, in a way that I don't really know how it's gonna be right now. We're gonna have to improvise. Yeah, I think you should, Anon. It's really fun. I was surprised by how fun this is to do, actually. So anyway, I'm not planning to write a lot of code today. I think what we are going to do is plan how random terrain generation in real time is even going to be possible. And I have opened this level here in Lunar Magic. Like I said before, the reason I'm doing 4 screens is because it's going to be easier to loop, and the random terrain generation and the looping phase, and the looping level, they're gonna be in the same phase, so they're going to be intertwined. We're gonna start by figuring out what random terrain generation even means, and I'm just gonna add some comments here to illustrate my point. Or maybe I'm gonna use paint, actually. Let's see here. Let's grab ourselves a paint window here. See, how big is it? Oh, this is huge. We don't need this much. Something like that, I guess. Is that good? It's also really huge. Is that good? I don't know. Like so. Very professional stream here. So let's see. What do we even need for this to be possible? We need... how do I even... What's the best way to show this? We're actually gonna use the debug option here, and I'm gonna show you something. Let's right, we can't skip through here. I'm so used to Extra Mario World. It's so nice to just be able to skip through everything. Always add skip options to your hacks. I start there. Alright, so what I opened here is the debugger, and from here I opened the tile map viewer. It's open here, and we're going to look at layer 1, set it to auto update. Let's pause the emulator, we don't need it to be opened. So, let's set it to ×2, it's a bit easier to see. So here we have it. This is how layer 1 looks in the game's memory. This part, this ground here, is pretty self-explanatory. It's what you see here on the bottom of the screen. And interestingly enough, the camera loops vertically. So when, as you can see, this is the bottom of the camera, but this is not the bottom of the ground in the tile map. The camera's bottom is here, and the top actually goes above here, and this part of the tile map is actually displayed at the top of the screen. It's pretty intuitive when you see it move, I think, and it's not that hard to understand. But yeah, this is something we have to remember, that this is not relative to the camera. The camera can be anywhere in this area here. And what is this? This thing looks like blue garbage. This is the part of the tile map that has not yet been loaded. When the level opened, this stuff was loaded right away to fill the first screen, and then this stuff has not yet been loaded. But if I unpause the game and we walk in that direction, you see that it fills in. And now, because all these screens look the same, we can't really tell which part the camera is on anymore, because it's gonna look the same regardless of which direction we go in. And we're actually going to use that to our advantage when we loop the level. We're gonna abuse the fact that the player can't actually tell where one screen starts and one screen ends, or one screen ends and one screen starts. It's the same sort of idea that was used in Super Mario 64 for the endless staircase, which, as some of you might know, is not actually endless. It just teleports you back, but there's no indication that it teleports you, so you can't really tell. It looks the same, so it feels like you're just moving on forever. That's what we're gonna do here. Probably we don't actually need 4 screens, probably 3 is enough. Maybe 2 if we're really clever, but that's it's easier with the more screens we have, the easier it's gonna be. So probably we're gonna have the camera like start here, and probably because screen 0 can be a little bit weird depending on how we place things, so probably we're going to loop like from screen 3 to screen 1. No wait, let me get that right. Let me get that straight. We're probably gonna loop from screen 2 to screen 1, and then we're gonna probably start on screen 0, but we're probably gonna start looping around here. And I don't know what we're gonna use screen 3 for, if anything, actually, but we might use it, we might not. It doesn't hurt us to have it there right now though. But this is the important thing. This is how the tile map looks in RAM, and if we look here, we can see, you can see here the position. These are the coordinates of the 8x8 tile I have selected. If we keep going here, you can also see that it has an address. This is the address in VRAM. This is what we have to know if we're going to write directly to this tile map, which we are gonna figure out a way to do. I don't know how that's going to look in this hack, but we're gonna figure out a way to do it. I'm gonna have to do some research before we actually do that though. I'm gonna have to look through some of the other patches used in the project and whatnot. Anyway, take a look at the address here. The address here starts at 6000 and it ends at 6FFE. So it goes the entire 6000 block. So it starts at 6000, and the next thing in VRAM after the tile map is going to start at 7000. And take a look now when I go from position to position here. 00 is address 6000, 10 is 6002, 6006, 6000E, 6018, whatever. It increases by 2 for every tile, right? Because each tile has 2 bytes. It's the tile number and the property byte, which is very similar to the form I use for sprites, except there are no XY coordinates here. They're just in an array with the X and Y coordinates determined by the order. So we keep going here, and now look as we go to 31 here, and as you might predict, we're on address 6003E. But look at what happens now when I take one step further to the right. We go to number 32. All of a sudden, we're on 6800. That's the address we're on. Why did this step go plus like 700 in CO? 700 in CD. Why did we go so much plus here? It's because and also you can see it doesn't actually say 32. Instead it says map 100. Here it says map 0 310. It's because the tile maps tile maps in the SNES memory are always the same size, or you can actually change the size a bit with some settings, but in Super Mario World they're always going to be the same size. They're going to be 32 by 32 8x8 tiles, but which is exactly the size of one screen, with some extra space at the top or at the bottom. But in order to scroll smoothly without the like glitchy effect you see in, for example, Super Mario Bros. 3 on the NES, you need more space in VRAM. So what you do is you just have two tile maps right next to each other. And the first tile map starts at address 6000. The second tile map starts at address 6800. And we do need to keep this in mind when, for example, if we want to generate random terrain and we put something here, let's say we put it here on this tile, it's probably going to wrap over into this tile map, and we need to take that into account when we're drawing it. And that's what I wanted to show with this, I guess. So we're going to take a little screen dump of this thing, and let's put it here. And here, let's just grab this and make a big, no, that's the wrong tool. Let's make a big red line just through here. This is one tile map, and this is another tile map. You can't see this in game. They look like they're just connected, which they are, but this is address 6000, like so, and this is address 6800. And this is going to make the like math when figuring out the address we write to a bit complicated. So we'll have to keep this in mind when we're doing this. So this is the first challenge we're going to face. It's actually not the first one, but it's the first one we're going through. We're gonna face it eventually. And also keep in mind, maybe someone is already thinking about this, I don't know. When we actually write to the address, this is the byte address. This is the address we see in the emulator in memory. But when we actually write to it, we have to use the word address. So this address is going to be halved. So it's actually, what we write to is 3000 and 3400. This is VRAM address, as in the address specified in register. Yes, Anon. This is exactly what I'm talking about right now. This is the address we see in VRAM. This is the address we write to register 2116, the VRAM address register. I just think using these makes more sense. These red numbers, the 6000 ones, they make more sense when we look in the emulator, because that's what we see there in the debugger. But when we write the address, we always have it. That's important. This is a byte address, this is a word address. If you have to learn one, learn this green one, because that's what you use. But it's also important to know that this one exists as well, right? Okay. Challenge 1, explained. Do I close this? I'll just make it small, whatever. Alright, we're going to close the debugger now. And let's see, what was I going to do with this one? Right, so what we're going to do is we're going to have some sort of system that takes pre-made chunks of map 16 tiles and probably just writes them to the map 16 data. So what we have in... I'm actually going to bring this thing up here. Let's see if they actually have the proper documentation for it. If you go in the map 16 table here, we're not going to use very much of this because the level is pretty small. But if we do look at it, we can see that the map 16 table for the level is stored at 7E-C800 and the same location bank 7F. Oh, I see. That's great news, Anon. That's great news. So let's see. What we have here is that... So we have the map 16 table here, and this table will be red when the camera moves. This table will be red, and the tile map in VRAM will be automatically updated to match whatever is in here. And we know a map 16 tile is 4 8x8 tiles, right? Everyone who's worked on Super Mario World hacks knows this. So we can have, like, let's say we have this tile. This is probably not what we're gonna generate, but let's say we do want to do this. Like, we have these 4 tiles, and they all have their tile numbers, and they all have their palette settings, and they all have their priority and their flip bits, and together that makes the YXP CCCTT byte. That's the property byte. It's very similar to the sprite property byte, but not quite. As you can see, there's only one P bit and there are two TT bits. Though Super Mario World doesn't actually load enough graphics to make full use of these. I think we can use settings 0, 1, and 2 in the TT bits, but we can't use the final setting of 3. And we also only have one priority bit, which is why in here we can only choose priority off or priority on. Yeah, so we can make use of this by just using the scroll routine. We can have the map 16 stuff be read. So if we write to the map 16 table to an area that is outside of the currently loaded tile map, when we scroll there, that is going to be updated automatically. So that's something we're going to make use of, and what we need to know for that to work is the format of the map 16 table. And it's a bit of a mess, or well, by that I mean it's not super intuitive, but it's also not super hard to learn. The low bytes of the map 16 numbers are stored in bank 7E, and the high bytes are stored in bank 7F, meaning that they're actually split in half. I had never do this because I thought that is very annoying to do. What do you think is very annoying to do, Anon? Map 16 stuff? So we can't just use 16-bit mode to read or write numbers right away. We have to make the numbers and then put half of them in bank 7E, half the number in bank 7E, half the number in bank 7F. That's how it's going to work. And how are they ordered? So at the start of the level, or at the very top left corner, is index 0. So this tile here is the low byte of this number is stored at address 7E-C800, and the high byte of this tile is stored in address 7F-C800. And let's actually take a look at this. I know we're going pretty slow here, but this is going to be really important. This is going to be really, really important. So let's put this here. Just this tile. I think this is tile number 130, right? It should be. Let's see. Yeah, 130. Oh yes, Anon. I'm not super looking forward to figuring out how to actually write to the tile map in real time. I don't even know how we're gonna do it, honestly. We're definitely not using stripe image. Stripe image is super banned from this project. But we're gonna figure it out. So this here, we place this at the top left corner of the level. This is the first address of the map 16 table. So let's just open it in the debugger. That's not wait, defines? What is this? Oh right, it's the it's the file I tried to include last time. Let's see. Yes, you're right. Stripe image is very horrible. If you want a tip, try using DMA mode 4 and just do the same format that you do for OAM. You have 2 bytes for the address, as in 2 bytes for X and Y, then you have 2 bytes for the actual tile and the property bytes. Let's go here. We're going to look in the memory editor. Alright, let's pause it so the boss doesn't kill us. And let's go on the address I said, 7EC800, and we can see here there are a bunch of 25s here, but the first byte is 30. What is 30? Well, it's the low byte of this, because this is tile 130, right? Or it's block 130. Let's be very, very careful not to use those terms interchangeably. A block is a map 16 tile, or a map 16 block, and a tile is an 8x8 tile, okay? Those are 2 very different things. And this is a block made out of 4 different tiles, right? And this is the low byte of that block number. Then we go into bank 7F-C800, and we see the high byte is 1. And all the empty tiles, or all the empty blocks, the air blocks, are number 0025, which we know is, well, if we go here to 5 here, a completely blank tile used by the game to fill empty areas in the level. If you're used to Minecraft, you probably think of this as an air block, which is what this is. It's just nothing. But anyway, we know that it starts here, top left. Makes sense, right? And then we have screens. And the way it works from here is that the low nibble, the low digit of the low byte, defines the column on the screen. So let's see, what do we open? We open, we can use this, I guess. No, what do we use? Do we use paint? Why not? So we have, let's get a better size. So we have 4 digits, right? 4 hexadecimal digits defining our offset to the table. Let's say that this is our index, right? This is index 0 up here. This nibble, or this digit here, what do we do here? Does this even make sense? So this here is the, let's see, this is X within screen. Not the camera, but the screen number in the level. Okay? And let's see, I think it actually doesn't really make sense to have this line here, because these 3 are used together, kind of. So, get this. And these 3 define everything else. And this is the complicated part. This is the complicated part. So, this is which row to start on, right? And this is going to be row 0, this is going to be row 1, row 2, row 3, and so on, all the way down here. And this is row 1B, I believe. Or maybe this is row 1A and this is 1B. Because this is how it works. It goes all the way down here from row 0 all the way to row 1. I think this is going to be row 1A. Let's see, isn't Lunar Magic supposed to show me the coordinates there? There we go, 26, what's that? That's 1A, I believe. Yeah, so this is row 1A, and then row 1B, the next one, starts here. And it goes all the way down here to row, what's this gonna be then? Row 36, I think? Is that right? It's pretty crazy if it's true. 26 times 2. 34 almost. And then the next one, row 35, starts here, on the next screen, here. And if you change the level's height in Lunar Magic, the offset for these changes as well. So, for example, if we doubled the screen height, this screen column here, number 1 or number 0, would go all the way down to whatever double this is. So instead of 1A, it would go to 34, and then 35 would start here. But we're gonna use this small screen size here, and let's see. No, we're actually going to make one change here. We're going to change this screen to 1C, because this is a number that is actually easier to work with, because it's going to make for rounder looking numbers. So this goes all the way down to 1B, and then 1C starts here, 38 starts here, and what's next? 44, I think? No, 38, 44, 54 starts here, and that's all we have to worry about. So when we write a map 16 system, or we want to generate terrain, if it's off screen, which is what we want to generate right now, we don't actually want to generate anything on the screen, except for when we destroy some blocks, but that's easy enough to do anyway. We just write the map 16 number to the appropriate location here. So that sounds pretty simple, right? So what we make is I wish I had something that was like more easy to see. Do we just make a Google Doc? Maybe we do. I think that's a pretty good idea. Let's see. Let's go open the design document again. Here. Let's make a new page. And let's have a, let's bump this up a bit, a lot, so it's easier to read on stream. Let's see. Terrain generation. Does that work? I guess it does, sort of. Yeah, let's go with it. So what do? We need have a, oh no, it has the auto thing. I hate this. Why is this on? I never have this on. No, we're not using Google Docs. We're not using it. We're using Notepad. You're gonna have to live with the small text, okay? So, what we need. A list. Actually, this is pretty stupid. I should just write this in the code file. I'm gonna put it there as a comment anyway. You know, now I feel silly. Okay, I'm gonna strike these because we already made them. Hit boxes, kind of made that already. Here. Yeah, I guess I do use Excel quite a bit, but not for like just viewing stuff. I usually use Excel to like calculate stuff en masse, I guess. So what we need for terrain generation plus loop effect, we need to have a list of objects that can be generated to create believable terrain. And then we need to randomly read from that list and write it to the appropriate VRAM locations. No, not VRAM locations. Map 16 offsets, table offsets. Okay. So all that work just for these 2 points. Not quite, but I've talked a little bit about other things as well. So if we just keep scrolling, when we get here, it's gonna stop, right? Because we can't go further than this. And if we didn't loop it, it could go all the way here, right? Which is pretty far. But if the player is like really slow to beat the boss and also doesn't die, it could go all the way here and they could die. So that's unacceptable. We need to loop it. And we're gonna have to get clever for this. My idea for this is pretty hacky, but I think it could work. And basically we need a mirror screen. We need one screen that is a perfect mirror of another one. And I guess I figured out what I'm using screen 3 for. So what we're going to do is whenever we write anything to screen 1 in the map 16 table, we also write it to screen 3, so that these 2 screens are always the exact same. So imagine we're in game, we generate this here, this 2 tiles in on screen 1. We also generate it here in the exact same location on screen 3. There's no mirror for screen 2, just for screen 3. And no, actually, now that I think about it, are we gonna need to do the same thing for screens 0 and 2, like this? Maybe, I don't know. I don't know if we actually need to mirror these screens. We're gonna test that. But basically what we're gonna do is we're just, when we get to a certain point, like let's say the camera is here, right? The camera is like this. We just snap it back here instead. No wait, where was I? Here. So we go -2 on screens. Yeah, so we're gonna need this as a mirror screen as well, I guess. So we go here, we just teleport the camera here, and we teleport, so we teleport the camera 2 screens back, we teleport Mario 2 screens back, we teleport the boss 2 screens back, we teleport all projectiles 2 screens back, and because these screens are identical, no one's gonna be able to tell that that happened. And something you might know if you have messed with the camera before is that if you move the camera without doing so from the actual scroll routine, you're going to mess up the tile map. Like the tile map I showed previously in like this tile map here, if we just teleport from here to somewhere else, this isn't going to update. What you see on the screen is not going to update. It's just going to remain whatever was already loaded there. And that's why it's so important that we have these mirror screens. So we update something here, right? And we scroll in and this is loaded. And then we jump here. If these two don't look the exact same, the player is going to be able to tell, because like they'll see this block here maybe. This block was here. Now, let's just do this the easy way. We remove this. This isn't here, but it's been generated here. And then we just jump here. The player can't see this, but they can still interact with it. Mario can't run through this. So like maybe you run here. Oh, you bonk an invisible wall. You try to jump, you land on this. You don't see this, but it's here. That's why we have to generate it in both screens at once. To make sure that even though the tile map hasn't updated yet, and actually won't update here at all, the player can't tell because it was already loaded here and it looks identical, right? So we start here. Whenever we get to... probably the way we do it is whenever we get to... so what we want to do, actually, I think this code is going to do it. Let's see. Let's put this in debug for now. It's going to be very simple. We're going to wrap. We're going to have the simplest wrapper ever. We take the camera position and we make sure that only these bits exist. These are the only bits allowed to exist here. So what does this do? This is the lowest bit of the screen number, so it can be screen 0 or screen 1, and I guess that means we're not really going to be using screen 3, eh? Wait, is this right? No, I think we're gonna need screen 3 actually. No, wait, this wrapper will never work. Because the tile map is a bit bigger than this than what you see on screen, so it actually extends a little bit here. So for example, we can never generate this with this setup. So what we're gonna do is we take this, we compare it to let's compare it to 2E. Oh, we don't want to compare it quite to 3. That's too far because let's think of the fact that the camera is actually a full screen wide. So we compare it to 2E00. That's one too many O's. 02EO. That's 2 tiles short of screen 3. We compare it to this. If it's less than this, whatever. Just skip this. But otherwise, we subtract 200, which is 2 screens. Exactly 2 screens. And do note that I'm BCC branching, so if it's here, we always have the set carry, so we don't actually need to do this. Slight optimization. Things like this sometimes matter when you're coding on the SNES. And we want to do the same thing for Le Mario. So let's do the same thing with... No, actually we just want to sync them. So whenever we're doing this, we also want to take Mario's position and subtract the same amount. And then, let's see, we want to loop over all sprites and do this for them as well. So let's see what this define is actually called. ASM, SO1 definition. Should be a pretty conspicuous label here. Sprite size, I think this is it. Yeah, and we can see it's this, but it's gonna be -1 because that's the highest index. Spur size disperse size -1. And we are going to have to go into 8-bit mode here, which kind of sucks. But it is what it is. No wait, this is actually way better because we're only subtracting screens. Why am I even in... Huh. Now that I think about it, we can go into 8-bit mode here. BCC plus, and we just XPA, and we just subtract 2 instead. Let's do it to B, because we actually don't want to mess with the low byte. We just want to mess with the high bytes. Let's see, did I give a name to this define? I did. Mario X plus 1, Mario X plus 1 sprite size, and we load X high, decrement by 2, store to X high, loop over all the sprite numbers. And we probably want to do the same for extended sprites and smoke sprites too. So let's see, we can remove these for now. They've been saved on stream, and I believe I know them by heart. So let's see, let's find all sprite types. Smoke sprite, right, they don't have a screen. They don't have XI, do they? They do not. Okay, extended sprite. See, extended sprite number, X position high byte, 1733, and there are that many of them. 33, address X, deck 2, wait, this isn't necessary. Is this better? We're actually going to count cycles here. Hold on just 1 second here. So let's see here. We go to, what I'm thinking, is this faster or is this faster? Reading, decrementing twice and storing it back, is that faster than just decrementing it twice like this? Let's see. Load address X, and this is, isn't it supposed to say how many cycles this is? There's how many bytes? 4? I guess this is cycles. 4 cycles. Store 5 cycles. 4, 5, and I know this one is 2 times 2, so 4. So this is 8, 13 cycles total, right? And deck address X, this is 7 cycles. 7, 7. This is 14 cycles, and this was 13. So as much simpler as this looks, this is actually 1 cycle slower. So we're gonna go with the above version. Slight optimization, but it's a little bit faster. So we're gonna go with it. Okay, so that's the extended sprites. That's the sprites, that's the extended sprites. What else do we have? We have, I don't think we're gonna have any bound sprites in this fight. They are not gonna be present. Quake sprites are not gonna be present. Score sprites, they are in fact going to be present if you jump on any projectiles or anything. Y movement, score sprite index. Do they not have a position? Surely they do. Oh, score 1-up sprite. X position high byte, 6 bytes. 5 is going to be the highest index, and then we load, let's see, what is this? 16F3. Address X, deck2, store it back. Okay, so we store that back there. So that's gonna move all the score sprites. And then we could do this with macros, but I'm actually typing it out now. We might change it to macros later, but typing it out to make it clear what I'm doing. So the X position high byte, that is correct. And then we have minor extended sprites. Here, number, X position low byte. All right, they're stored somewhere else, probably because they figured later that they need them. X position high byte, there are 12 of them. So we're going to load B as the highest index. 18 EA, is that right? (18EA), that is right. Minor extended sprite X position, and there are that many of them. Dex BPL minus, and there we go. That should do it. That should move the camera 2 screens back. Should move Mario. Should move all the sprites. Should move minor. Should move extended sprites. 1-up and score sprites, and minor extended sprites. Okay, let's go. Let's test it. And like I said, we should expect this to crash. Oh right. Of course, I keep forgetting these. I have underscores here. Maybe I should just get rid of those. I keep forgetting they exist. Will it hurt me to get rid of these? Probably not. X, low. High, Y low, X high, like so, and then we make it. All right, let's test this, see if it works. If it works, we should, did we jump back? Did we do it? Did we do it? Oh wait, you can totally see that it's happening. I wonder why. Okay, it's pretty clear that that's happening. Could it be that the, did the boss despawn? He shouldn't have. Where did he go? Where'd he go? Maybe I warped him off screen when the... maybe he was... Okay, maybe the boss was like here when the camera looped and he got teleported off outside the level. Maybe that happened, I don't know. In which case that's an argument for moving this whole thing once, like a couple screens to the right, I guess. Okay, so you can totally see that the camera is like bonking here. Let's see. Yeah, around here, right? Let's see, frame advance. There. So Mario's in the right place, but the camera is not in the right place. This is not because of the screen border here, or the level border here, because there's a full screen there, pretty much. So I'm guessing this is due to the camera routine's internal registers that are used to keep track of where the camera was on the previous frame. Because Super Mario World's camera is actually pretty clever. It like, keeps track of how far Mario has moved inside the screen and stuff to know when it should move. So you get like this nice little buffer, so you can do like small movements like this, right, without the camera like spazzing out like crazy. You have to move pretty far for the camera to figure out that you're moving, right? So maybe this is happening because the camera thinks Mario should be here, right, on this part of the level for the camera to move, and then all of a sudden he's 2 screens here, so the camera just jumps forward. Maybe something of the sort is happening. I think that's what's causing this error here. And of course, this is not a massive issue. Like, we're not getting any tears or big glitches or anything. It's just that it's pretty obvious when this is happening, right? And that's what we don't like. We don't like that this is obviously happening. So close that, and Now we dig around in the RAM map and try to figure out when the world is happening. So we're going to search here. Camera. There's a lot of hits. Just gonna go, let's go from the top. Oh, no, no, not waiting addresses, no! Back off! Okay, here. Camera, let's go. I don't think we need to mess with these. These are for the timelapse uploaders, whatever. We're gonna have those be handled automatically. In horizontal levels. Don't need those, that's how big the level is. Controls if the camera should move to be at the proper place compared to the player. If this is set, L and R are ignored. Normal case, don't move camera automatically, keep it in place, assuming L and R aren't used. So I'm guessing this could be relevant. I don't actually know. Sorry to any camera chads that might be watching, I don't actually know how to do this. So you're gonna see me in the process of doing some research. Suspects 1400 related to LR. Probably not. I don't think it's likely that this is the problem, but I'm gonna save it anyway. What is this? Set to 80 if you bounce off a springboard. Irrelevant. Vertical and horizontal settings. Irrelevant. Layer 2. Irrelevant. Two 16-bit addresses. 14.2C and 14.2E. Okay. Okay, are set to this. Okay, during the screen scrolling routine. Read from to determine whether or not to scroll the screen. Could this be it? Is this Mario's screen relative position? Where the player has to be on the screen in order to justify moving the screen. But this is screen relative. So I don't think it's gonna be this. This is screen relative, and we're moving both Mario and the screen the same amount, so screen relative position should remain the same, right? But 14.2A, maybe? Okay, I have, if we don't find anything here, I still have one guess, and I hope this is not the case, but it absolutely could be. Overworld, irrelevant. And we're back at the top. Okay, so it's probably what I think it is, which is not gonna be funsy times. This is actually the worst case scenario. What I think it is Lunar Magic's edits to the scrolling routine that are messing with us. And let me explain what I mean here. Unless I actually have something better to guess. Do I have a better guess right now? Or am I going to go, am I gonna go ballistic? Let's see. Let's see, do I have anything else? Anything else? I really don't think I have anything else right now. Wait, maybe we do, maybe we do. Okay, actually I have layer 1 position. What is it called? Next frame? I have one guess. Yeah, this one. I don't know why this one doesn't show up as camera because it's clearly related to the camera. We're gonna try messing with this one as well, and maybe that will help. Okay? We'll try it. Like I said before I almost started a rant, I know that Lunar Magic does make a lot of changes to the camera routine, and I know that when you're messing with the camera that can sometimes cause you to run into problems that seem inexplicable because they are not documented in all.log, they're not really documented in the RAM map, and people on the forums don't really know about it. So that would be the worst case scenario for this. But we are going to do this. We take... let's see, the index probably makes this better. Right now it is 2116 in my country, Anon. I I believe you can see this here. Maybe this is too small to see on screen, but this is the time for me right now. 2116, 2117, amazing. So we want this 1463 address. And I do have my first day of school for this semester tomorrow, so I'm gonna go to bed pretty soon. We're gonna decrement those two as well. Is there anything else? There is Mario's position next frame, right? Calculated ahead a bit. Next frame. Player X position within level. Next frame. What about this one? D1? Is this ever used by anything? I don't know. Here. Player X position 16-bit within the level. Current frame. I think this is just last frame, right? Anyway, we'll decrement D2 as well. Also, this here is probably ridiculous. Let's just deck this twice instead of doing this stuff. Yeah, okay. And I believe for DP this is quite a bit faster than loading and decrementing in A. Okay, let's see. Does this make a difference? Does it make a difference? Whoa, whoa, whoa. Okay, come on, boss. Follow me. Follow me, my child. Okay, it worked, I think. Only layer 2 didn't respect it at all. Layer 2 got bonked. Right, of course. It's because layer 2 has this has variable scrolling, right? So layer 2 actually moves back 1 screen, but layer 2 is 2 screens wide. So yeah, okay, we got the loop going. We got the loop working. Loop is indeed a working. We could expand this to 8 screens for layer 2 to not be a problem. I don't think we're gonna do that though. That seems that would be very obnoxious when we actually make the terrain generation go online. So what do? I guess the easiest option is to make sure we have a layer 2 that is perfectly mirrored. So this here is gonna be the exact same as this stuff here. That's gonna be the easiest way. So let's kill this and let's copy this, and then let's smooth over the inconsistencies. This thing here, let's just do that to make sure we remember. So this thing here is going to go there. We kill that. Stuff goes here. Is there a tile that matches this? Is there? I don't know. There probably is, but I removed it. No, there isn't. Wait a minute. Oh, right, here. Wrap. And now we should be pretty much good to go. Okay, we need a replacement tile for this thing. Page here, no? Where is it? Here? Is this the one? I think so. Yeah, that's the one. Let's go. We are on row F. That's very, very good. Let's get rid of this one. We don't need that cloud. And let's replace that tile as well. Okay, we should be good to go. Now we just grab this, place it there. Oh no, that didn't work. Right, it goes here. There we go. Wait, it still doesn't loop. Right, this thing isn't quite right, is it? So this one starts here. there, I guess. And then, are there any good tiles to place here? This is not what I should be spending time on. But I already started it, and I'm gonna finish it, damn it! There. There. And then we just place these, I guess. Like so. Does that do it? Does that do it? Almost. This one goes there. And there. Place that there. And now we have a background that will loop properly on this screen wrap. Let's test it. Boss, follow me. Follow my orders. Whoa, whoa, what? What's this? What's this? The level is looping indefinitely. The boss is following me. The smoke is working properly. The level is looping. Isn't that awesome? Yeah, you can't tell anymore, right? The level just loops. Very, very epic. We made it, gamers. Where's the boss now? We do probably have to add a check so the boss doesn't like teleport off screen here, which I think he just did. Because if he teleports off, like if his position is less than 200, he's gonna teleport outside the level and die. Or I guess it doesn't actually despawn, it's probably just falling infinitely down. Because it doesn't despawn off screen. But yeah, it loops indefinitely. You really can't tell anymore. Everything seems perfect. We might run into errors later, I'm sure we will. But for now, we have set up the loop. We have laid out the groundwork for how the terrain generation is going to be. Or like we have theory crafted it, right? And we spent quite a bit of time on that. And that's important. That's very important to do. It's gonna save us a lot of headache later. But anyway, that's gonna be it for today. And the one time I name the stream episode ahead of time, I name it wrong. Because we're gonna change it to from random terrain generation introduction to actually I guess it can still say that, because most of the stream went to introducing terrain generation and the tile maps and stuff. But yeah, so this is like half the work we need to do to get phase 1 going. But that's gonna be it for today. I'll be back tomorrow, probably after my class, maybe before, I don't know, depends on how spry I feel in the morning. But yeah, that's it. Remember to never like, never comment, never subscribe. I'm not a professional YouTuber, so I don't have to say that. In fact, if you click the bell, I will come for your head. No wait, I think you can't say that. Please don't ban me. Anyway, whatever. Do what you want, have fun. I hope you enjoyed the stream. I'll be back tomorrow. Love you guys. Goodbye.